Can you see the screen? Can you see the screen?
Yes, sir. Yes, sir.
Right, carry on. Book paper తీసుకొని రెడీగా ఉన్నాను, నా ప్రాబ్లమ్స్ వస్తాయి.
Very good morning, students. Welcome to another lecture on radar systems. In this lecture, we are going to discuss some basic.
Can you hear the voice? Ramya?
Yes, sir.
Can you hear the voice?
Yes, sir.
Problems on radar systems. And before going to that, we are going to discuss some important formulas. Okay. So, first of all, we need to find out the range of the radar. The range of the radar is given by capital R, which will be equals to C into TR by 2, where TR is the round trip time. Okay. And the next one is maximum unambiguous range. R unambiguous is equals to C by 2FP, twice of false alarm. Okay. Next one. The basic radar equation is R max equals to PT. I have written GT, no problem. G into AE by AE into sigma by 4 pi whole square into S min whole to the power of 1 by 4. Where gain of the antenna G is equals to 4 pi into AE by lambda square. Okay. Next one is noise figure of a receiver. Noise figure of a receiver can be written as Fn is equals to N0 by KT naught into Bn into Ga. It can be also written as Fn is equals to Si by Ni divided by S0 by N0. We have already discussed these things in the prediction and range performance. Okay. If the maximum bit atomic signal S min is that the value of Si corresponding to the minimum ratio of the output IF SNR S0 by N0, then the necessary detection, then the minimum signal necessary detection is equals to S min is equals to KT naught into Bn into Fn by S0 by N0 minimum. Okay. And the modified maximum possible range in terms of IF amplifier output, SNR ratio and noise figure.
All of you, please make a note of those formulas. ప్రతి ఫార్ములాని రాసుకోండి. బ్రీఫ్గా కంప్లీట్గా చాప్టర్ మొత్తాన్ని కలుపుకున్న మనకు ఫార్ములాస్ ఉన్నాయండి. ప్రాబ్లమ్స్లో ఇచ్చేది అలా ఇస్తారు కాబట్టి జస్ట్ మేక్ ఏ నోట్ ఆఫ్ ఇట్. ప్రతి ఫార్ములాని రాసుకోండి. ఇఫ్ యూ వాంట్ టైం, సార్ ఫాస్ట్గా వెళ్ళిపోతుంది, కొంచెం టైం ఇవ్వండి అని ఎవరైనా చెప్తే నేను ఆపుతానండి. ఓకే.
Equals to R max whole power of 1 by 4 equals to PT GT AE sigma by
సార్ వాయిస్ అసలు వినిపించలేదు సార్.
ఏమ్మా ఏనా
ఫార్ములా వాయిస్ అసలు వినిపించట్లేదు సార్.
Vn into Fn
ఇప్పుడు వినిపిస్తుందా?
minimum. These values we have discussed in our radar equations.
Can you hear that one now?
The relationship between probability of false alarm, probability of detection,
స్లోగా ఉంది సార్.
అమ్మా స్లోగా ఉందా? స్లోగానే ఉంది నాయన. వెనక ఒక బ్యాక్గ్రౌండ్ కొంచెం డిస్టర్బ్గా ఉంది, కాసేపు అయిన తర్వాత ఫాస్ట్ అవుతుంది. ఓకేనా? ఓకే
ఓకే సార్.
probability of false alarm equals to 1 by TFA, time factor for the false alarm into B. And probability of false alarm can also be expressed as exp of minus Vt square by 2 psi naught. So see here, TFA is equals to 1 by V1F into exponent of Vt square by 2 psi naught. By using these formulas only, we are going to prove some problems, and these problems may be asked in your final examination. Albertian experimental relationship between signal to noise ratio, probability of false alarm, and probability of detection is given by S by A. That is, probability of false alarm is equals to A plus 0.12 AB plus 1.7 into B, where A is the logarithmic value of 0.62 divided by probability of false alarm, and B is equals to logarithmic value of probability of detection divided by 1 minus probability of detection. And the radar range equation with n integrated pulses. Here previously we have discussed taken only minimum. Suppose n integrated pulses maximum value will be equals to R max for 4 is equals to PTGT AE sigma by 4 pi whole square KT naught Bn into Fn into S by n whole power n. So integration efficiency is equals to EI of n. In order to find out the efficiency, integration efficiency, EI of n is equals to S by n of 1 by n into S by n of n. Here 1 is nothing but initial value, and if you have taken n number of samples, then we need to include this one. Okay. See the last one. The final radar equation including integrated efficiency with n radar pulses is given by R max whole to the power of 4 is equals to PT G AE into sigma n EI of n, okay, by 4 pi whole square KT naught Bn into Fn into S by n of 1. Okay. By this we are going to finish our formulas. So make a list out of these formulas and keep this one in mind. Coming to the next one, we will go for the problems now. For the first one, example 1, a certain radar has a PRF. What is PRF? What is PRF? Okay, a certain radar has a PRF of 1250 pulses per second. So what is the unambiguous range? We need to find out the R unambiguous value. So we need to find out the R unambiguous value. So we have a formula that R unambiguous is equals to C by 2FP. Okay, so C by 2FP means probability of C is nothing but velocity of light. Therefore, that is value equals to 3 into 10 to the power of 8 meters per second, and by 2 into FP what they have given as 1250 meters. Therefore, 3 into 1.8. So what is PRF? Pulse repetition frequency. Okay, so that means that is equals to 3 into 10 to the power of 8 divided by 2 into 1250 meters. It will be equals to 120 into 103 meters, and it will be equals to 120 kilometers. Okay, I repeat, we have given our pulse repetition frequency, and we need to find out the maximum unambiguous range. So in order to find the maximum unambiguous range, we have a formula R unambiguous is equals to C by 2 into FP. Okay, and FP is nothing but pulse repetition frequency. will be equals to PRF or FP, whatever means, no problem. Okay. C is nothing but velocity of light. C value is equals to 3 into 10 to the power of 8, 3 into 10 to the power of 8 meters per second. So we have substituting those values. Okay. Coming to the next example, a shipboard radar has 0.9 microsecond transmitted pulse width. So here they have given PW, pulse width, they have given pulse width. So two small boards in the same direction are separated in the range by 150 meters. They have given the distance also. So will the radar detect the two boards as two targets? Okay, I repeat the question. A shipboard radar has 0.9 microsecond transmitted pulse. Pulse width is 0. Time is 0.9 microseconds. Width. So two small boards in the same direction are separated by two small boards are separated by a distance 150 meters. Will the radar detect the two boards as two targets? They would have separated two boards, right? So we need to find out whether it will accept the two boards as two radars or not. So see here, the radar range resolution. We need to find out the resolution. The radar range resolution. The range resolution of the radar is its ability to distinguish two closely spaced targets along the same line of sight (LOS), and the range resolution is a function of the pulse length, where pulse length is equals to C into tau by 2. Tau by 2. It is a two-way range corresponding to the pulse width. Okay. That means it has to detect as two targets. See, for finding that range, radar range resolution is equal to what they have given. Radar range resolution is equals to C into tau by 2. It is they have given a sorry, they have given a transmitted time, that is 3C means 3 into 10 to the power of 8, that is 10 to the power of 8 only, 108 for 10 to the power of 8. C into 10 to the power of 8 into, they have given 0.9 microseconds, that is 0.9 into 10 to the power of minus 6 by 2, which will be equals to 135 meters. Okay, since the two boards are at 150 meters apart, which is greater than the range resolution, that means we have identified, that means these simple targets can identify up to some distance only, that means its value is, that means here the range resolution is only 135 meters, but since the boards are at 150 meters, that means they are 15 meters apart, means the boards are at 150 meters apart, which is greater than the range resolution of 135 meters. Therefore, the radar can detect the two boards as two separate targets. That means if the two targets are within the range, then will be treated as one target. If they are exceeding the radar resolution range, then they will be treated as two separate targets. Okay. Into the next one. A pulse radar transmits a peak power of 1 megawatt. Okay, and it has a PRT, pulse repetition time, equals to 1000 microseconds, and the transmitted pulse width is 1 microsecond. So they have given peak power, that is 1 megawatt PT, and they have given PRT is equals to 1000 microseconds, and the transmitted pulse width is equals to 1 microsecond. Then we need to calculate the maximum unambiguous range, average power, duty cycle, energy transmitted, and the bandwidth. As we have already seen in the first example, we have calculated maximum unambiguous range. Maximum unambiguous range is equals to C into TP by 2. We have, what is the TP value? 1000. C means standard velocity of flight, that is 3 into 10 to the power of 8 into 1000 into 10 to the power of 6 by 2, which will be equals to 130 into, sorry, 150 into 103 meters, and it will be equals to 150 kilometers. That means maximum non-navigation is clear signals can be obtained up to 150 kilometers. Okay, next one, average power is equals to PP into tau by TP. That means they have given uh, they have given micro pulse width, that is 1 microsecond, that is 1 into 10 to the power of 6, 1 into 10 to the power of minus 6 by 1000 into 10 to the power of minus 6. Okay, 1 into 10 to the power of minus 6 by 1 microsecond, right, divided by 1000 into 10 to the power of minus 6, which will be equals to 1000 watts, and that will be equals to 1 kilowatt. So we need to find out, the next one is we need to find out the duty cycle. Duty cycle is equals to tau by TP. Tau is equals to 1 into width, that is 1 into 10 to the power of minus 6 by 1000 into 10 to the power of minus 6, which will be equals to 0.001, and the energy transmitted is equals to P into tau by, that means peak power into tau, time, peak power into time, that is 1 into 100, 1 into 106, that is because 1 into 10 to the power of 6 into 1 into 10 to the power of minus 6, which will be equals to 1 joule. And the last one is bandwidth. Bandwidth equals to 1 by tau, which will be equals to, here the tau value is 10 power minus 6. Here the tau value is 10 power minus 6. Tau is equals to 10 power minus 6. Here this is 10 power 6 only. Okay, 10 power 6, not 106. This is 10 power 8. Okay, this is also 10 power minus 6. Please make a note. In the correction only, 10 power 6. This is 10 power minus 6. This is also 10 power minus 6. Just make a small note. Okay, this is also 10 power minus 6. This one also 10 power minus 6. Okay, here also 10 power minus 6. Okay, we'll go for the next one. See here, first fourth example, if the bandwidth of an IF amplifier in a radar receiver is 1 megahertz, and if the threshold to noise ratio is 12.8 dB, determine the false alarm time. We need to find out the false alarm time. Here TF is equals to nothing but false alarm time is equals to 1 by BIF, okay, into exponent of VT square by 2 psi naught, VT square by 2 psi naught, where VIF is equals to 1 into 106, sorry, 1 into 10 to the power of 6 hertz, 1 into 10 to the power of 6 hertz. So we need to find out the threshold to, first of all we need to find out threshold to noise ratio. They have given threshold to noise ratio is 12.8 dB. So it will be equals to is 10 into log of 10 into V square by 2 psi, V square by 2 psi, which will be equals to 12.8 dB. Okay, and V square by 2 psi is equals to anti-lava curve of 12.8 by 10, which will be equals to 19.05. Okay, we need to find these values also. Before calculating that TFA, we need to find these values. So I repeat, so TFA is equals to 1 by VIF into exponent of VT square by 2 psi naught. So we need to find that they will give you VIF value is equals to 1 into 10 to the power of 9, 10 to the power of 6 hertz. They have given receive time is equals to 1 megahertz. Receive time is equals to 1 megahertz. So we need to convert it to hertz. Then threshold to noise ratio is equals to, they have given threshold to noise ratio is equals to 12.88. So that means 10 log 10 into V square by 2 psi is equals to 12.8 dB. That means this value is equals to 12.8 dB. So V square we are going to calculate. V square by 2 psi is equals to anti-logarithm of 12.8 by 10. That will be equals to 19.5. Therefore, substitute these values here. TFA is equals to 1 by BIF is equals to 106 into EXP of V square by 2 psi naught value is equals to 19.05, and that value will be equals to 18763328 divided by 146106, and which will be equals to 187.6 seconds. So please, while doing these problems, try to solve yourself. Okay, and try to identify what they have given in the question. We'll go for the next one. So the probability density function, density of the envelope of the noise voltage out is given by relay probability density function. We have already given relay probability and relay density function. My square, my region, like that. They have given a relay probability density function. It is P of R is equals to R by psi naught into exp of minus R square by 2 psi naught, where R is the amplitude of the envelope of the filter output of R naught, and if PA, probability of false alarm, is needed, which will be equals to 10 to the power of minus 5, and determine the threshold level. Then we are finding the threshold level. So the probability of false alarm in terms of threshold level is given by PFA, probability of false alarm, is equals to exponent of minus VT square by 2 psi naught, exponent of minus VT square by 2 psi naught. They have given if PFA needed is 10 to the power of minus 5, that is probability of false alarm equals to 10 to the power of minus 5. Here we are substituting that value. Okay, here they have already determined that is PFA is equal to 10 to the power of minus 5. So we are writing in an expression form, that is probability of false alarm. Okay, see, the probability of false alarm in terms of threshold voltage is given by probability of false alarm equals to exponent of minus VT square by 2 psi naught, which will be equals to 10 to the power of minus 5. And in order to find out the threshold value, we have taken logarithm on both sides. That is here also we have taken logarithm, and here also we have taken logarithm. It is 5 minus 5 into 5 into log e base 10 is equal log e log 10 base e is equals to minus vt square by 2 psi naught. Okay, it will be equals to minus 5 into log 10 base e is equals to 2.3026 into vt square by 2 psi naught. Okay, we need to calculate vt square. That means okay, vt square is equals to, this value will be equals to 11.5 into 2 psi naught, 11.5 into 2 psi naught. So we need to calculate vt, that's 5. Vt is equal to square root of 23, that is 11.5 into 2 is nothing but 23, square root of 23 into square root of psi naught, which will be equals to 4.8 into square root of psi naught. Okay, go for the next. See here, the bandwidth of an IF amplifier is 1 megahertz and the average false alarm time that could be tolerated is 15 minutes. Find the probability of false alarm. Given the bandwidth of an IF amplifier is 1 megahertz. I have given the bandwidth that is 1 megahertz, 1 megahertz bandwidth, and the average false alarm time could be tolerated is 15 minutes. False alarm. So find the probability of false alarm. See here, the relationship between average false alarm time and the probability of false alarm. We need to find out the TFA, average false alarm time, and probability of false alarm, TFA. And the IF bandwidth P is given by probability of false alarm is equals to 1 by tolerance of false alarm into B. Okay, so substitute V is equals to what they have given, the bandwidth is equals to 1 megahertz, that is 10 power 6, 10 power, that's it one, 10 power 6, 10 power 6, and TFA is equals to 15 minutes, that is 9, and we need to convert this 15 minutes in terms of seconds, that will be equals to 900 seconds. Then we get PFA, probability of false alarm, is equals to 1 by TFA, that means 1 by 10 to the power of minus 6, 10 to the power of 6 is equals to 1.11 into 10 to the power of minus 9. Okay, that's what answer. So if you want to find out the exact value, just do the necessary calculations. Go for the next one. What is the ratio of threshold voltage to the RMS value of the noise voltage necessary to achieve the false alarm time? So we need to find out the ratio of threshold voltage with respect to the RMS value. So this is found out using the relationship with as probability of false alarm equals to, as we have seen in previous one, probability of false alarm equals to exponent of minus Vt square by 2 psi naught, minus Vt square by 2 psi naught, from which the ratio of the threshold voltage to RMS value of the noise voltage is given by, you need to find out the Vt, right? So Vt by psi naught is equals to 2 into logarithm of 1 by PFA. Okay, 2 into logarithm of 1 by PFA. It will be equals to 2 into log of 1 by PFA, probability of false alarm they have given. So we have taken the maximum value, that is 9 into 1, so 2 into logarithm of 1 by PFA. Here PFA will be equals to 9 into 10 to the power of 8. 9 into 10 to the power of 8. That means see, have they given any value? What is the ratio of threshold voltage to the RMS value of noise voltage necessary to achieve this false alarm time? So we have some standards. By using those standards we have implemented this. That is equals to 2 into logarithm of 9 into 10 to the power of 8, which will be equals to 16.2 decibels. Okay, coming to the next one. The typical parameters for a ground-based research radar is, first one, pulse repetition frequency they have given 300 Hz, beam width 1.50, and 2 they have given 2 beam widths, and antenna scan rate is 5 rpm. That means 5 revolutions per minute. That means 300 per second. And find out the number of pulses returned from a point target on each scan. They have the scan rate. That means it is scanning 5 RPM. That means 300 per second. 300 scans per second. So we need to find out the number of pulses returned from the target point on each scan. How many pulses are hitting to the target and how many pulses are returning to the target? We need to find out those values. So the number of pulses returned from the point target on each scan is given by NB. So number of target points, that means the number of scanned points which are returned from the target will be given by NB, and this NB will be equals to theta B into FP by theta S, okay, which will be equals to theta B into FP by 6 WM. Okay, substituting the above values, you get what they have given. So theta is nothing but 1.5. So beam width 1.5 into. So frequency rate is, what is pulse repetition frequency rate? 300 hertz. That is equals to 300 divided by, so 30. It will be equals to 15. I repeat, I have given pulse repetition frequency which is 300, beam width which is 1.3, 1.5 and 1.53, and the antenna scan rate is 5 RPM. So we need to find out the number of pulses returned from the point target on each scan. How many pulses are returned from the point target while performing one scan rate? So they have given, and it can be calculated by using NB is equals to theta B. Theta B is nothing but your beam width into FP, that is pulse repetition frequency, divided by scan rate, that is a 300. Okay, so the values will be, if we are going to substitute these values here, then our value will be equals to 15 number of pulses. 15 number of pulses are returned from the point target while performing each scan. So these are some of the problems, and in the previous and in the next class we are going to, if possible, we are going to solve some more problems, or we'll go for the next chapter. Thank you.
So what is your next chapter? So the next chapter is MTA radar, moving target indicator radar. మీ ఎగ్జామ్స్ ఎప్పుడు స్టార్ట్ అవుతాయండి? GT ఎగ్జామ్స్ ఎప్పుడు స్టార్ట్ అవుతాయి? Is there any information from the college? శాంతి ప్రియ, ఏమైనా ఇన్ఫర్మేషన్ ఉందండి కాలేజ్ నుంచి? ఎగ్జామ్స్ ఎప్పుడు స్టార్ట్ అవుతాయని?
సెకండ్ నుంచి షెడ్యూల్ వచ్చింది సార్.
ఓకే, అంటే ఇప్పుడు మళ్ళీ మీకు ల్యాబ్ ఎగ్జామ్స్ అన్న పెడతారా ఇప్పుడు?
ఎక్స్టర్నల్ ఎగ్జామ్స్ తర్వాత ల్యాబ్ ఎగ్జామ్స్ ఉంటాయని ముందే షెడ్యూల్ వచ్చింది సార్.
ఎక్స్టర్నల్ అయిపోయిన తర్వాత ల్యాబ్ ఎగ్జామ్స్ ఉంటాయా?
మిడ్ ఎగ్జామ్స్ అన్ని మార్నింగ్ సెక్షన్లో ఉంటాయి.
మిడ్ మార్నింగ్, ఎక్స్టర్నల్ ఆఫ్టర్నూన్ రాసినట్టయితే. సరే సార్. Like we can exit the class.